Today we're going to be working through lecture notes 2. These notes will be on density and then on converting units using factor label method. You should have your notes in front of you, and you will also need a calculator in order to do some of the density problems. In the before class notes, you had a chance to look at the density equation and to do a few simple calculation problems. We're going to review the density equation and make sure you really understand how it works and how to solve different problems with it, because you will be doing a lab on density that corresponds to this lecture. Okay, so our definition for density is how tightly packed the atoms in an object are. So we need to think about the atoms. Let's zoom in on two balls. Okay? Let's say this first ball is made of metal, and the second ball is made of plastic. Okay? Probably from your everyday experience, you already can visualize what these look like and how they would feel if you would be holding them. Okay, the metal ball, we would say, is very dense. Okay, its atoms are going to be super tightly packed together. There's a lot of atoms for this given volume or this size. Okay, what would we say about the plastic one? They would be less densely packed. It has a lower density. Okay, maybe the atoms are more spread out. Okay, a metal ball is very dense. A plastic ball is less dense. So hopefully that kind of gives you a visual of this definition. All right, so how do we actually calculate density? You need an object's mass, and you're going to divide it by its volume. Density is mass divided by volume. Mass is typically measured in grams. And for this class and for the lab, you will measure mass in grams. For volume, you will measure it in milliliters. Milliliters. So you're just going to take mass divided by volume, and you will get density. Okay? Plugging in mass and volume is pretty easy in order to calculate density, but sometimes we will want to find one of the other variables. If you're really great in algebra, that's going to be easy for you to rearrange that equation. If algebra is a little bit harder for you to visualize, I have this handy triangle trick. Okay, so if you draw a triangle, kind of split it up with a T, you can put in your density equation. Density is mass over volume. And what's cool about it is all you have to do is take your finger and put it over what you want to find. If we want to know the density, mass divided by volume. Well, what if we want to know the mass of an object? We would take density times volume. Okay, so this triangle trick can be used to solve any of the variables in the density equation just by putting your finger over what you want to find. Okay, so let's try two problems together. A metal pipe has a mass of 4.6 grams and a volume of 12.8 milliliters. We want to know the density. We need to take mass divided by volume. So if we plug in what they gave us, we would have 4.6 grams for the mass, 12.8 milliliters for the volume, and you'd put that in on your calculator. Okay, remember we talked last lecture about sig figs. We don't need to record all of these digits on the calculator. Okay, I used a number that had 2 sig figs going in and another number that had 3 sig figs. So let's round this to 2 sig figs. We would round this to 0.36. Okay, so that's a practical example of when you should have sig figs in mind to give me an appropriate answer for the question that we're doing. So I have 0.36, but it's naked. It needs some units. The units for density are going to be the units that you used going into it. So we have grams per milliliter. And that's what we would have for our density of this metal pipe. Okay, let's try a problem together where we want to find something other than the density. Okay, here it says, what is the mass? We don't know the marble's mass, but we know its density and we know its volume. When you want to find mass, you're going to multiply density times volume. Okay, so if we plug in 2.5 grams per milliliter times the 1.9 milliliters, we can find the mass. And I get 4.75. We could round that to 4.8 to keep 2 sig figs. Okay, let's look at the units. My milliliters are going to cancel, and I'm left with grams, which makes sense because I was asked to find a mass. So you can always ask yourself, do these units make sense for what I'm trying to find? One thing that's handy to know is the density of water, because we put a lot of objects in water and we want to know how they relate to water's density. Water has a density of exactly 1 gram per milliliter. Okay, so it's pretty easy to relate other objects back to water. So if we put something in water and it has a density greater than 1, it's going to sink. If we have an object with a density less than 1, it will float. Okay, so hopefully that helps you with some density problems, and that should give you enough information to take it into the lab activity and apply it. Okay, let's flip over and look at something called the factor label method. Before I talk to you about factor label method and how we use it, over here on the side I have a metric conversion chart. We learned last week how to convert King Henry died unexpectedly drinking chocolate milk using that little saying. It's also possible to use a conversion chart, whichever one you think is easier. But the way that this works is all of these prefixes, one of those is equal to this number in our base unit, which is meter, liter, gram. So I could say 1 kilometer is equal to 1,000 meters, or 1 centimeter is equal to 0.01 meters. So you would say one of these is equal to this many of the base unit. And we'll do some practice with those later on down this page. Okay, you're going to hear the term factor label method quite a bit in chemistry. And it's a way of converting units. You're always going to start by putting what you are given over 1. And I would say this is the central rule of factor label method. Okay, you're going to use a conversion factor, one of these, or another conversion factor that's given to you in the problem. And then our units need to cancel top to bottom. Okay, so let's jump right into a problem so you can see how these work. I love factored label method, and I know that seems really silly and probably kind of nerdy, but it just makes sense, and if you stay organized in your work, you can convert one thing to anything else as long as you have a conversion factor. Okay, so we're going to convert apples. We're going to do something silly for the first one. How many apples can I get for 20 bananas? Your first step is to take what you are given and put it over 1. Okay, and you're going to set up your problem like this. I have bananas, but I don't want them anymore. So I need that unit to cancel by putting it in the denominator. I don't want bananas, but I have a conversion factor to go to apples. If I put bananas in the top and cancel them in the denominator, I can find apples, which is what I want to find. Well, what do I put here for the conversion factor? They've given it to us. 2 apples is equal to 3 bananas. Okay, so once you have your units set in place, then you just fill in the conversion factor given. You always want to check that your units cancel top to bottom. Bananas on top cancels with bananas on bottom, and you're left with apples, which is what you want to find. Okay, so if you were to punch this in your calculator, you're going to multiply straight across on your numerator. 20 times 2. You can probably do that in your head, but let's plug it in just so we can do it together. 20 times 2. And then you divide by 3 after you've pressed equals. 20 times 2. Now you're going to divide by 3. And that's really important because sometimes these calculators get confused if you're dividing the 20 by 3, if you're dividing the 40 by 3. You want to do this first operation, press equals, and then divide by 3, and you should get 13.3. You could round it to 13 if you want. I'm just going to write 13.3, and my unit would be apples. I converted to what I wanted to find. I'd like you to start setting up this next problem. You should always be able to start with your given number over 1 and then go from there. Okay, you can see we have 2 conversion factors this time, so we'll probably need to use both of them. If we're starting with apples and we don't want apples, where should you put the label apples? You're going to put it in the bottom so that it cancels. Okay, if we look at our conversion factors, the only one we have that has apples in it is 2 apples equals 3 bananas. So we're going to have to use that one first. 2 apples gives me 3 bananas. Oh, well, that's not what I want to find, so we need to keep going. I don't want bananas, so I should put them in the bottom to cancel them. But I do want oranges. And that's good because we have a conversion factor that can switch us to oranges. 5 bananas make 7 oranges. Before you do any calculating, let's check our units and make sure they cancel. Apples on top, apples on bottom, bananas on top, bananas on bottom. Yay, we're left with oranges. Let's practice properly putting this into our calculator. You're going to multiply straight across the top. 6 times 3 times 7 equals, now we're going to divide by 2, because it's in the denominator, equals, and divide by 5. Divided by 5 equals, and we get 12.6. If you're not getting 12.6, it's probably a calculator error, most likely with how you punched in the denominator. Okay, we're dividing by 2, dividing by 5. It's in the denominator. 12.6 is our answer. And our label would be oranges. Okay, so now that we've tried some examples with fun things like fruit, let's try using the factor label method to convert some measurements in the metric system. So this one says, my cat weighs 9,070 grams. How many kilograms is this? Okay, so we're going to take our starting number with its unit, and we always put it over 1. Okay, just like we did in the last two problems, we're going to be canceling units top to bottom. So if I don't want grams anymore, they need to come to the denominator so that they cancel. Okay, we have a conversion factor that we can use to switch from the prefix kilograms to grams. Okay, remember 1 kilogram is equal to 1,000 of whatever base unit, like grams. So let's use that conversion factor. 1 kilogram is equal to 1,000 grams. We always want to make sure our units cancel top to bottom, and we're left with kilograms, and that's what we want to find. So this one's pretty easy to plug in to your calculator. 9,070 divided by 1,000. You could probably do that in your head. We should get 9.07 kilograms. Okay, I'd like you to take a second to begin setting up the next example. The length of a fingernail is 17 millimeters. How many decimeters is this? Okay, so I'm going to take my given and put it over 1. One thing you might notice as you're looking at this problem is that we don't have a conversion that can take us from millimeters straight to decimeters. Okay, we know a conversion to go from milli to meters and from deci to meters. So right off the bat, we would know that this is a two-step problem. Okay, so first let's work on getting rid of millimeters. I'm going to put millimeters in the bottom. That'll take us to our base unit of meters. Let's go up to the chart and grab that conversion factor. Okay, we know that 1 millimeter is equal to 0.001 of our base unit, which would be meters. 1 millimeter is equal to 0.001 meters. Okay, so that cancels millimeters. Now we're in meters. We don't want that anymore. We want decimeters. Okay, our conversion works the same way. 1 decimeter is equal to 0.1 meters. Let's check that we canceled units correctly. Millimeters on top, millimeters on bottom, meters on top, meters on bottom. Yay, we're left with decimeters. If we put this in our calculator, remember we're always going to go straight across the top with our multiplication. 17, make sure you guys can see that, 17 times 0.001 times 1, press equals, then you're going to divide by 0.1 because that's in the denominator. 0.17. Decimeters. Okay, the last problem says how many seconds are in 4.5 hours? Okay, I want you to take a couple minutes to work this problem out on your own. When you think you have it, press play. You can pause it for a few seconds to try to work it out and see if you really have the hang of this factor label stuff. Okay, so here's what I came up with. I put my 4.5 hours over 1, and I know a conversion factor that can take me from hours to minutes. 1 hour equals 60 minutes. And once I'm in minutes, I know that 1 minute is equal to 60 seconds. Let's check our canceling of units. Hours cancel, minutes cancel, and I'm left with seconds. So on your calculator, you would just be multiplying straight across the top. You would be taking 4.5 times 60 times 60. And we would get 16,200 seconds for your final answer. Okay, so hopefully that gives you a taste of factor label method. I'm not sure if you think it is as much fun as I do, but hopefully you see that if you stay very organized and you're very good about canceling from top to bottom, you really can convert anything, whether it's fruit, whether it's things in the metric system, or something like time. This is a super useful tool for many calculations that you will do in this class.